Alright, so in the last video we mentioned that an identity is something that's true for every single x value, whereas an equation is only true for some. Here are a list of the most commonly used trig identities, and this is courtesy of Professor Paul Dawkins. He's a math professor at Lamar University in Pennsylvania. But the ones that you'll use most often are, first of all, these reciprocal identities. Okay, cosecant is the reciprocal of sine. So what that means is if sine is equal to 4 over 5, cosecant would be the reciprocal of that. It would be equal to 5 over 4. And you can see the other ones here, sine and cosecant, secant and cosine, cosine, secant, and so on. Okay, tangent is also sine over cosine. Since cotangent is the reciprocal, that means it's cosine over sine. And then these three right here are maybe the most important ones. Those are called the Pythagorean identities. So before we get into actually doing examples, I want to prove these three to you right now. Okay, so let's prove why these are true. And they're called Pythagorean. You might be able to tell by looking. This is the Pythagorean theorem. A squared plus b squared equals c squared. You can see that all of these have items being squared. Let's understand why that's true. So let's start with sine squared plus cosine squared equals 1. This means that for any triangle, if you take the sine of an angle and you square it, and then you add that to the cosine of the angle and square that, it will always equal 1. Okay, let's understand why. So here's a triangle. Let's call that angle theta. It doesn't matter where we place the theta. We'll just put it right there. Okay, this side right here is opposite to theta. This side is adjacent to theta. And this is the hypotenuse. Okay, we'll also label these A, B, and C, just like in the Pythagorean theorem. Okay, so let's use our acronym SOHCAHTOA, which means that the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Let's use that for this right here. So the sine of theta squared, okay, because that's what we're dealing with right here. What would the sine of theta squared would be? Well, the sine of theta is opposite over hypotenuse, and we're squaring that. So I'm going to write that as O squared. That means opposite squared over H squared. Okay. Then after that we have the cosine squared of theta. Okay. So the cosine squared of theta will be this. Cosine didn't come out quite right. Cosine squared of theta. Well, the cosine is equal to adjacent over hypotenuse. So the adjacent squared in this case over hypotenuse squared. Okay, and we'll just abbreviate that as a squared over a squared. And what is that going to equal? Well, think of it this way. O squared, obviously when you're adding fractions together you need a common denominator. We already have one here, so it's going to be h squared. And the top is going to be this. The top is going to be O squared plus a squared. But now look at this triangle. O squared is this thing. O squared is like your b squared. And a squared is like that thing. So what is, in a right triangle, what is this side squared plus that side squared? It equals this side squared. So another way of saying opposite squared plus adjacent squared, another way of saying that is this hypotenuse squared is h squared over h squared. What is h squared over itself? It equals 1, and that's what this is supposed to equal. So that is a proof of the Pythagorean identity. The sine squared of any angle plus the cosine squared of any angle equals 1. So where do these other two come from? Well, let's start by proving this one. Suppose that I take this identity right here that we just proved. That's supposed to be a theta right there. Suppose I take that identity and I divide everything in it by cosine squared. Okay, and you can do that because as long as you do something to one side, you can do it to the other. Okay. What is sine squared over cosine squared? Well, we have another identity for that over in this list right here. Let me move it for a sec. Sine over cosine is equal to tangent. So sine squared over cosine squared equals tangent squared. Cos squared over itself, that's this one, is 1. And what's another name for 1 over cosine? Another name for 1 over cosine is secant. So that equals secant squared theta. And sure enough, we just proved another one of those identities, that one right there. Okay, then let me show you one more. Okay, the last one would be 1 plus cotan squared is cosec squared. So now let's take this same identity that we just had, sine squared plus cosine squared. And this time we will divide everything in here by sine squared. Okay, just to see what happens now. See if you can jump ahead on this and figure out what's going to happen. So we're dividing everything by sine squared. So this, sine squared over itself equals 1. Cos over sine is cotangent. That's an identity. Cos over sine, so that's going to be cotan squared because each of these are being squared. And then 1 over sine is another identity. 1 over sine is that right there. It's cosecant. Okay, And actually I should be writing the thetas, I often forget to do that, but there's that third identity. So these three are the most important identities. In the next video, what we're going to do is now practice using those identities to find trig values.